Students and faculty, welcome to the 2022-2023 Jump into STEM student competition. My name is Dr. Ryan Meyer, and I'm a research engineer at the National Renewable Energy Laboratory, or NREL, as well as I'm a part of the Jump into STEM management team. This is a short recording describing and providing background and additional information for one of this year's 3 challenge topics. For additional information, please visit our JUMPintoSTEM.org webpage, where you will find everything related to the competition, including rules, submission requirements, as well as information about the other challenge. The following presentation specifically discusses the CurbYour Carbon challenge, decarbonizing US buildings. Globally, buildings account for more carbon emissions than any other sector. That's an important statement. In the US, the residential and commercial building sectors combined account for almost 30% of US emissions. Please note, this does factor in the impacts related to generation and the distribution of electricity, which is very important to our building sectors. Also, although there are a number of other greenhouse gases, all of which contribute to climate change, carbon accounts for more than 75%. And by carbon in that instance, I mean CO2 or carbon dioxide. So let's take a look at how and why our buildings emit carbon. There are 2 primary forms of carbon emissions when we talk about buildings. First of all, buildings consume energy. This includes electricity and any other fossil fuels such as natural gas, propane, fuel oil, you name it. Carbon emissions due to this energy consumption is known as operational carbon. Then there are carbon emissions related to materials, manufacturing, construction, material transportation, demolition, or any other construction-related process. These are known as embodied carbon emissions. Today, at least statistically, operational carbon emissions are greater than embodied. But these 2 types of emissions do not happen at the same time during a building's life cycle. And as buildings become more energy efficient, this proportion, the proportion between embodied and operational carbon, will change. So let's take a look at this paradigm a little more closely. When a building is constructed, there is a significant amount of embodied carbon emissions. This chart here represents, a new construction for a typical building starting in 2020. You can see the upfront embodied carbon emissions in yellow on the left of the chart. You can also see a couple additional embodied carbon spikes throughout the 30 years that are depicted here. And these represent, at least generally speaking, renovations over the course of 30 years. Similarly, each year, you'll see an amount of operational carbon release. This is depicted in the blue bars. You'll also see this number is reducing over time. This is assuming that perhaps the building is becoming certainly ever more energy efficient as it can, but also considering that over the course of time, as we have clean, renewable energy generation, any energy that the building does consume will have less and less carbon emissions emitted. Now, take a closer look at the first 10 years of this building's lifetime. Embodied carbon emissions represent about 39% of all carbon emissions during those 10 years, and this is for a typical new construction building. We compare that to a high performance or very energy efficient building, then we see that 2/3 of the emissions during the first 10 years are related to embodied. Of course, as we move along in time, these proportions change. And of course, for any individual building with specific details, these proportions may look different. But generally speaking, we must consider carbon emissions throughout the life cycle of a building and not just instantaneous moments in time. Also, as global populations grow and as buildings are built and or they reach the end of their life, we can quickly see how reducing carbon emissions is a multifaceted problem. So we should begin looking for opportunities to address both embodied and operational carbon in order to achieve our long-term objectives. This is our motivation for this year's Jump into STEM Curb Your Carbon Challenge. Buildings need innovative and effective ways to reduce any and all carbon emissions. Now, students, there are numerous innovative solutions that will be needed in order for us to solve and reach our long-term objectives of a carbon-free grid. In order to guide you on your quest, let's provide a little more guidance on these topics in hopes that it might spark some curiosity. Let's start with embodied carbon. Again, let's consider the life cycle of a building. It's depicted slightly different in this chart. But as you'll notice, embodied carbon emissions are relevant at many different phases. What you should see here, which is what I see here, this means you have many or multiple opportunities for solutions at different phases of a building's life. Now, the architecture and design community has spent a number of years addressing embodied carbon, and it has led to significant changes in what we call our typical design practices. For example, renovation and reuse of existing buildings where we are able is an excellent way of reducing embodied carbon. We're not building a new building. This can be analogous to when we reuse or repurpose building materials. We don't need new materials. Similarly, industry organizations, as well as certification programs such as LEED, have aided this change. So LEED stands for Leadership in Energy Efficient Design. And it incentivizes designers and contractors to both specify and procure low carbon materials, to reuse and repurpose existing materials, to divert waste, as well as seek locally sourced materials to reduce any carbon emissions related to that material's transport. For more information discussing specifically how LEED certification programs incentivize low carbon materials, I recommend searching LEED on the USGBC's website, where there's plenty of resources available to you. But what else could be done? Perhaps you've heard of carbon negative materials or carbon capture, or maybe carbon sequestration. So more recent advancement in materials are unlocking opportunities for pulling carbon out of the atmosphere and essentially injecting it into material permanently, which is sequestering it. Now you may be asking yourself, what did I just say? Okay, so let's take concrete as a basic example. Generally speaking, concrete is a composite material. It's made of an aggregate that is bonded together with cement that will harden or cure over time. Now, cement, or maybe you've heard of Portland cement, is typically produced by baking crushed limestone rock with other materials at high temperatures. This process not only requires the fuel to heat the mixture, but the calcium carbonate inside the limestone releases carbon dioxide during this process. So new material advances, and here I'm not going to give any secrets away, but they have found methods to make concrete without cement that even undergo chemical reactions during their creation to consume additional carbon dioxide. This is where the concept of carbon negative materials comes into play. Now, although concrete is one of the most common building materials in the world, it is certainly not the only one. So students, what other advances in materials can you find that could allow us to capture carbon? And by capturing it either during the manufacturing process or perhaps actively once installed on a building. Okay, our other type of carbon emissions are operational carbon. And again, just to remind you, basically this comes from the fact that our buildings consume energy. Certainly, there are many opportunities for new and innovative solutions that further reduce our energy consumption and subsequently our operational carbon emissions. In fact, electrification is its own Jump into STEM challenge topic this year, if you're interested anyway. And that topic focuses specifically on eliminating the use of fossil fuels in buildings. Other ideas could include controls that can operate buildings or communities and perhaps communicate with the utility grid to ensure that any energy we do consume in our building or our community is as carbon free as possible. There could be a lot of ideas here. I don't want to give them all away, so I'll just leave it at that. Now, lastly, as you embark on searching for a problem to solve, one that is for a specific stakeholder group, it will be important to consider the simple fact that we all do not consume carbon the same. For example, research has shown there is a relationship between carbon emissions and socioeconomic status. Some data suggests that higher income may disproportionately contribute to an increase in operational carbon emissions. Yet at the same time, often higher socioeconomic status leads to influence over policies that could specifically impact carbon emissions. It's also important to consider that the highest socioeconomic status represents the smallest proportion of our population. So do we need solutions that specifically address those, or should we be looking elsewhere? So not only are we seeking innovative solutions that are accessible to all, we also want to make sure that those solutions address the specific problems of our stakeholder group we are trying to help. Students, we are looking for you and your team to develop an innovative solution that will reduce carbon emissions in our buildings. You're welcome to focus on any aspect related to carbon emissions, embodied carbon emissions, operational carbon emissions, as well as capture and sequestration. Ultimately, this is your challenge. Now, the following 2 slides contain links to various references for topics covered in this short video. These hopefully will help point you in the right direction for finding a problem that you and your team want to solve. Also, keep in mind, these additional resources are not meant to be exhaustive. They are here to provide you context and a starting point for your own investigation. You can also look at the challenge description where additional references are cited. If any student or faculty has a question, please feel free to reach out to the Jump Into STEM management team at any time. Thank you and good luck.